So in this problem, we're going to find what we're going to be working with Young's double-slit experiment. And the problem reads, in a Young's double-slit experiment, the wavelength of light used is 457 nanometers, and the separation between the slits is 1.2 times 10 to the negative 6 meters. Determine the angle that locates the dark fringe for m equals 0, the bright fringe for m equals 1, the dark fringe for m equals 1, and the bright fringe for m equals 2. So, we were given here the wavelength in nanometers, and we were given the distance between the slits in meters. And already, since the units are different, we know we're going to have to convert this to meters, which would make it this number is wrong, sorry. It's supposed to be 520. It's supposed to be I think 1.4. So yeah, these 520 nanometers would then become 520 times 10 to the negative 9 meters. And that's what we would use in our calculations, this value. So moving on, we're going to determine the various angles that locate the dark fringe for m equals 0, bright fringe for m equals 1, dark fringe for m equals 1, and bright fringe for m equals 2. Okay. So for dark fringes, which are in between bright fringes, we use the formula sine of theta equals parentheses m plus 1/2 parentheses all of that multiplied by the wavelength divided by the distance between the slits. So for the first one, we're given that we're finding the dark fringe for m equals 0. So you insert 0 here, and that means that sine of theta just equals the wavelength over distance over 2 distance. So you plug your numbers into your calculator, and this should give you 0.1857. And then once you have this number here, you're not done. You have to take the inverse sine of that number in order to find the angle. And for this step, make sure your calculator is set to degrees instead of radians. So once you do the inverse sine of 0.1857, you should get a number of 10.70 degrees. So that is the angle that locates the dark fringe of m equals 0. And then for bright fringes, the process is a little different. It's a slightly different formula. For bright fringes, sine of theta simply equals m multiplied by the wavelength divided by the distance. So in this case, for this one, we have m equals 1, which is convenient. So you just do the wavelength, 520 times 10 to the negative 9 meters, divided by the distance, 1.4 times 10 to the negative 6 meters. Once you have that, you'll get this number here, 371 times 10 to the negative 3. Then you do the inverse sine of that number, and you'll get a number of 21.8 degrees. Then you repeat the dark fringe formula for the dark fringe m equals 1 instead. This time m of course equals 1, so you do 1 plus 1/2, which is equivalent to 3/2 as we see here. Otherwise it's the same. And for bright fringe, instead of m being 1 as it was previously, m is now 2, so you do 2 times the wavelength divided by the distance. Inverse sine, and then you get an angle in degrees. So that right there is how you find the various angles for bright and dark fringes in a double slit experiment.